Now let us understand the concept of conservative and non-conservative forces. What are conservative forces and what are non-conservative forces? Listen to the definition of a conservative force. A force is said to be a conservative force if work done by a force do not depend upon the path followed. Also, work done by a force in complete round trip, that is in complete closed trip, remains equal to 0, then the forces are said to be conservative forces. Gravitational force, electrostatic force, spring forces are examples of conservative forces. Potential energy of a system is always calculated only in conservative force field. The forces which are not conservative in nature are known as non-conservative forces. So whenever work done by a force depends on path followed by a body and work done in round trip do not remain equal to 0, then forces are said to be non-conservative forces. Potential energy of a system is never defined in non-conservative force field. What are non-conservative forces? Frictional force, viscous force, air drag force are some examples of non-conservative forces. Now, how potential energy of a system is defined? The potential energy of a system is always defined in a conservative force field. Potential energy is a reference frame dependent quantity. The change in potential energy of system U final minus U initial equal to negative of work done by the system, that is equal to minus integration F dot dr. Now listen to what is principle of conservation of mechanical energy. When work done by external force remains equal to 0 or external forces remains present, then mechanical energy of the system remains conserved. So dear student, when conservation of mechanical energy is applied, either when external forces are absent or when work done by external forces remains equal to 0, then mechanical energy of the system remains conserved. And what is mechanical energy? Mechanical energy is the sum of kinetic energy and potential energy. What is kinetic energy? Kinetic energy of a particle of mass m having velocity v is half mv square. So according to principle of conservation of mechanical energy, kinetic energy initial plus potential energy initial equal to kinetic energy final plus potential energy final. We can also write U initial minus U final equal to K final minus K initial. Loss in potential energy equal to gain in kinetic energy. This is known as principle of conservation of mechanical energy. But this principle can be strictly applied only in conservative force field. If conservative force field is there, principle of conservation of mechanical energy can be applied. So in gravitational force field, electrostatic force field, spring force field, we can apply principle of conservation of mechanical energy. But if forces are non-conservative nature, we cannot apply principle of conservation of mechanical energy. In that situation, we have to apply work energy theorem. Work energy theorem can be applied in all situations. What is work energy theorem? Work done by conservative forces plus work done by non-conservative forces plus work done by extra agent equal to change in kinetic energy of the system, that is K final minus K initial. As we know, work done by conservative forces equal to minus in bracket U final minus U initial. Work done by conservative forces equal to negative of change in potential system. So we can write W non-conservative plus W external equal to K final plus U final minus K initial plus U initial, that is equal to E final minus E initial. What is E final? That is final mechanism. What is E initial? Initial mechanism. So work done by non-conservative forces plus work done by external forces equal to change in mechanism. Suppose if change in kinetic energy is 0, then work done by non-conservative plus work done by extra agent equal to change in potential energy. And if change in potential energy is equal to 0, then work done by conservative plus work done by non-conservative plus work done by extra agent equal to change in mechanism. If change in kinetic energy is 0, then work done by non-conservative plus work done by extra agent equal to change in mechanism, that is equal to change in potential energy. So in every situation you can write work done by non-conservative plus work done by extra agent equal to change in mechanism of the system.